Good afternoon, students. In the last class, we discussed some forces which we are using in mechanics, right? So that is non-contact force and contact force, right? So few more forces in contact force. So in that first one is force due to a spring. Force due to a spring, right? So consider one horizontal surface. So on this horizontal surface, consider one block of mass m, right? So on to this block, connect one spring, and the other side of the spring is connected to the rigid surface. So there are lines not drawn out, right? Represents the rigid surface, right? So here also the horizontal table represents. So this surface is also the rigid surface, right? So here the force which is due to the spring. Here contact force means one object is in contact with the another object. So a block which is connected to the spring. So here there exists a contact force, right? So now when we apply the force onto this block, so ಇಲ್ಲಿ ಯಾವುದೋ ಒಂದು ಫೋರ್ಸ್ ನಾವು ಈ ಬ್ಲಾಕ್ ಮೇಲೆ ಅಪ್ಲೈ ಮಾಡ್ತಿದೀವಿ ಅಂದ್ರೆ ಸೊ ಈ ಬ್ಲಾಕ್ ಏನಾಗುತ್ತೆ ಇಟ್ ವಿಲ್ ಮೂವ್ forward direction. So as the block moves forward direction, then the spring gets compressed, right? So spring ಏನಾಗುತ್ತೆ ನಮಗೆ compress ಆಗುತ್ತೆ. When we apply the external force onto the blocks will move forward direction and the spring gets compressed, right? So force apply ಮಾಡ್ತಿರೋದು towards the positive x-axis along the horizontal. So initially the block is at this position and finally the blocks moves a small distance. So that distance will be taken as delta x. So block ಏನಾಗಿದೆ ನಮಗೆ displace ಆಗಿದೆ. When we apply the external force onto this block, the spring gets compressed. So ಇಲ್ಲಿ ಏನಾಗುತ್ತೆ ನಮಗೆ spring ಏನಾಗುತ್ತೆ compress ಆಗುತ್ತೆ, right? So now when we remove this force, so compress ಆಗಿದೆ, ಯಾವಾಗ ನಾವು ಈಗ ಅಪ್ಲೈ ಮಾಡಿರೋ ಫೋರ್ಸ್ ನ ರಿಮೂವ್ ಮಾಡಿದ್ರೆ ಆಟೋಮ್ಯಾಟಿಕಲಿ ಬ್ಲಾಕ್ಸ್ ಏನಾಗುತ್ತೆ it moves in the backward direction. That means the block is moving means there is a force which is acting in the opposite direction. So ಈ direction ಇಂದ ನಮಗೆ ಏನು ಆಕ್ಟ್ ಆಗ್ತಾ ಇದೆ force act ಆಗ್ತಾ ಇದೆ. So that force is because of the spring. So compress ಆಗಿರೋ spring ಅಲ್ಲಿ ನಮಗೆ ಏನು ಬರುತ್ತೆ the force. So that force we call as the restoring force. So the restoring force which is always opposite to that of the applied force. So anta force na navenanta ಕರೀತೀವಿ restoring force. So this restoring force is present in the spring, right? So ಇದನ್ನ ನಾವು ಎರಡು ಕೇಸಸ್ ಅಲ್ಲೂ ಅಬ್ಸರ್ವ್ ಮಾಡಬಹುದು, right? So force positive x axis compress ಮಾಡ್ತಾ ಇದೆ spring na, that is by the block, right? So same example if we take so here is the block. So ಇದನ್ನ ನಾವು ಫಸ್ಟ್ ಕೇಸ್ ಅಲ್ಲಿ ಸ್ಟಡಿ ಮಾಡಿದ್ರೆ so here in the second case now force is applied to the negative x axis. That means we are pulling this block. So block ನಾವು ಈ ಕಡೆ ಎಳಿತಾ ಇದೀವಿ ಅಂದ್ರೆ spring ಕೂಡ ಏನಾಗುತ್ತೆ it gets elongated, right? So somewhere here the block of mass m, right? So initial position of the block is this point and final position is again it gets displayed some position. So after removing of the applied force either push or pull, so ಎರಡನ್ನೂ ಕೂಡ ನಾವು if we remove the applied force then what happens again the blocks will comes to its original state. So ಇದು original state ಗೆ ಬರಬೇಕು ಅಂದ್ರೆ again the force which is constrained in the spring, so that force again we call as the restoring force. So that is also present in the spring, right? So now applied force ಗೆ opposite direction ಆಗಿ restoring force ಇದೆ. So that's the restoring force in opposite direction to that of the applied force. So So diagram ನೋಡಿದ್ರೆ ನಿಮಗೆ ಗೊತ್ತಾಗುತ್ತೆ. Applied force along negative x-axis is restoring force towards the positive x-axis. So here the applied force towards the positive x-axis, the restoring force is towards the negative x-axis. That means restoring force is opposite to that of the applied force, right? Restoring force, that is equals to applied force. So ಎಷ್ಟು ನಾವು force apply ಮಾಡ್ತೀವೋ ನಮಗೆ ಅಷ್ಟೇ restoring force ಕೂಡ ಸಿಗುತ್ತೆ, right? So now we need to find how much restoring force is getting from the spring, right? So the force we are pushing the block, that means the force is restored. So we are going to calculate this force, that is the restoring force, right? So force ಈ ಕಡೆ ಆಕ್ಟ್ ಆಗ್ತಾ ಇದ್ರೆ displacement opposite direction ಅಲ್ಲಿ ಆಕ್ಟ್ ಆಗ್ತಿರುತ್ತೆ. That's why the restoring force is equals to minus kx. So this is the formula of the force which it is constrained in the spring. So our force na navenanta karitivi restoring force, and that is equals to minus kx. So restoring force is directly proportional to x. So if we remove the proportionality, we getting the constant. So that constant is k. Why we are taken minus means as displacement is vector, so displacement force, applied force ಈ direction ಅಲ್ಲಿ ಇದೆ ಅಂದ್ರೆ displacement also is in the same direction, right? So applied force ಮತ್ತು displacement ಎರಡು same direction ಇದೆ. We are going to calculate the restoring force, right? So restoring force is opposite to that of the applied force. That means it is opposite to that of the displacement. So restoring force ಈ ಕಡೆ act ಆಗ್ತಿದೆ ಅಂದ್ರೆ displacement opposite. That's why we are taken minus, where k is a constant. So that constant we call spring constant or force constant. So this value will depend on the nature of the spring. So now ಯಾವ material use ಮಾಡಿರ್ತೀವೋ ಆ material ಮೇಲೆ ಈ k value depend ಆಗಿರುತ್ತೆ, right? So ಎಲ್ಲ spring ಒಂದೇ material ಅಲ್ಲಿ manufacture ಆಗಿರಲ್ಲ. So different springs will manufacture in different materials. So steel in the spring irutte, iron in the springs irutte. So on that factor k is depends. So restoring force is directly proportional to the displacement. That means it is directly proportional to the applied force. So ನಾವು ಎಷ್ಟು force apply ಮಾಡ್ತೀವೋ ಅಷ್ಟು restoration force ಕೂಡ ನಮಗೆ produce ಆಗುತ್ತೆ. So that force is equals to minus kx, where k is a constant. So this k value is depends on the nature of the material of the spring, right? So this is about the restoring force. So compress ಆಗಿರಬಹುದು. So in this case elongation, compression or elongation, in both cases we getting the restoring force. So ಇಲ್ಲಿ ಕೂಡ ಅಷ್ಟೇ. So applied force is towards the negative axis, but the restoring force is towards positive axis, right? So along the horizontal towards the positive axis. So applied force ke direction again irutte namage displacement. So if you observe here, displacement and restoring force both are opposite in direction, hence we take a negative. So eradu cases allu kuda in case 1 and case 2 we are getting the common force. So that one is the restoring force. So now idana horizontal table togondiddivi. In the same way we can take in the vertical also, right? So this spring is connected with the block of mass m. So ಇದಕ್ಕೆ weight ಜಾಸ್ತಿ ಆಗ್ತಾ ಹೋದಂಗೆಲ್ಲ spring ಏನಾಗ್ತಾ ಹೋಗುತ್ತೆ, elongation ಆಗ್ತಾ ಹೋಗುತ್ತೆ. So in that case the restoring force, that is equals to minus ky. Why we are taken y means we are taken displacement along y axis. So that's why we have taken that one as minus ky, and here we are taken x, that is displacement along positive x axis or negative x axis, right? So this is about the force due to a spring, right? So problem solve ಮಾಡಬೇಕಾದ್ರೆ ನಾವು ಇದನ್ನ ಯೂಸ್ ಮಾಡ್ತೀವಿ. So in detail ಆಗಿ ನಾವು ಇದನ್ನ oscillations ಅಲ್ಲಿ ಸ್ಟಡಿ ಮಾಡ್ತೀವಿ. So oscillations ಇನ್ನು ಮುಂಚೆ ಇಲ್ಲಿ force ಬಗ್ಗೆ ಸ್ಟಡಿ ಮಾಡೋದ್ರಿಂದ small part, that is for the formula. So ನಮಗೆ ಯಾವುದೇ ಪ್ರಾಬ್ಲಮ್ ಅಲ್ಲಿ ಸ್ಪ್ರಿಂಗ್ ಬಂತು ಅಂತ ತಕ್ಷಣ force we going to calculate by using the formula minus kx. And the next one is tension, or we call that one as force in a spring. String and spring, two difference here. So force in a string, we call that one as tension. So force due to a spring, we call that one as a restoring force, right? So ಯಾವುದಾದ್ರು ಒಂದು heavy object, if we suspend the object of heavier mass m, so there is, so string is nothing but either it may be a thread or it may be a metal. So ಯಾವುದಾದ್ರು ಆಗಿರಬಹುದು. So that one we call as a string. So this string is inextensible and massless. So ಇದಕ್ಕೆ ಯಾವುದೇ ತರದ್ದು mass ಇರೋದಿಲ್ಲ, that means negligible mass ಇರುತ್ತೆ. And inextensible means, so as we discussed in the spring, so spring ಗೆ ನಾವು force apply ಮಾಡಿದ್ರೆ spring compress ಆಗುತ್ತೆ, ಜೊತೆಗೆ expand ಆಗುತ್ತೆ. So ಆ ಪ್ರಾಪರ್ಟಿ ಇಲ್ಲಿ ಇರೋದಿಲ್ಲ. So ಅದು extensible material. So ಇದು non extensible, that means ನಾವು ಎಷ್ಟೇ ಲೋಡ್ ಅಪ್ಲೈ ಮಾಡಿದ್ರು ಕೂಡ ಈ ಥ್ರೆಡ್ ಮೇಲೆ ಅಥವಾ ಈ ಸ್ಟ್ರಿಂಗ್ ಮೇಲೆ ಇದು ಏನಾಗಬಹುದು ನಮಗೆ, it will not increase its length or it may not decrease its length, right? So that type of material we call as inextensible, right? So inextensible ಅಂದ್ರೆ ಯಾವುದಾದ್ರೂ ಒಂದು ಲೋಡ್ ನ ಹ್ಯಾಂಗ್ ಮಾಡಿದ್ರೆ ಆ ಥ್ರೆಡ್ ಅಥವಾ ಆ ಸ್ಟ್ರಿಂಗ್ ಲೆಂತ್ ಏನಾಗಬಹುದು ನಮಗೆ ಚೇಂಜ್ ಆಗಬಹುದು. The length will remain constant. So 100 centimeter length ಇದೆ ಅಂದ್ರೆ ನಾವು 1000 kg ಹಾಕಿದ್ರು ಆ ಸ್ಟ್ರಿಂಗ್ ಲೆಂತ್ ಎಷ್ಟು ಇರಬೇಕು, 100 ಇರಬೇಕು. So that type of material we call as inextensible string, right? So here the force will be getting in the string, so that force we call as the tension, right? So that's we denoted by T, where tension is also a force, so that we will observe in an inextensible massless string, right? So that type of force we call as the tension. So here the force constant is more. So force constant ನಮಗೆ ಜಾಸ್ತಿ ಇರೋದ್ರಿಂದ, so ಇದು ಏನಾಗಲ್ಲ ನಮಗೆ ಥ್ರೆಡ್ ಅಥವಾ ಸ್ಟ್ರಿಂಗ್ ಎಕ್ಸ್ಟೆಂಡ್ ಆಗೋದಿಲ್ಲ, right? So that one force we call as tension. So ಯಾವುದಾದ್ರೂ ಒಂದು ಆಬ್ಜೆಕ್ಟ್ ಗೆ ಈ ತರ ಥ್ರೆಡ್ ಅಥವಾ ಸ್ಟ್ರಿಂಗ್ ಅಲ್ಲಿ ನಾವು ಕನೆಕ್ಟ್ ಮಾಡಿದೀವಿ ಅಂದ್ರೆ always there is a force. So that force ನ ನಾವು ಏನಂತ ಮೆನ್ಷನ್ ಮಾಡ್ಕೊಂತೀವಿ, tension ಅಂತ ಮೆನ್ಷನ್ ಮಾಡ್ಕೊಂತೀವಿ, right? So but tension is also a force which will be observed that in the string or in thread, right? So thread are the right? So these are the few forces which we are going to discuss in mechanics, right? So ಇದು clear concepts, ನಿಮಗೆ problem solve ಮಾಡಬೇಕಾದ್ರೆ ideas ಇರುತ್ತೆ. So our main concept is friction. Right? So last class now discuss ಮಾಡಿದ್ವಿ. Friction is a contact force which is a component of a, that is horizontal component of a contact force. That force we call as a friction. So if we define friction is a force which opposes the relative motion of the object in contact. So this gives what the definition of the friction. So friction ಅಂದ್ರೆ friction is a force, right? Friction is a force which opposes, that means it resists. Oppose means resist, right? Which opposes the relative motion of the objects which are in contact, right? So if we consider any two objects, right? So I am considered this one as one object and consider one more object. So this one is the second object, right? So these two objects are in contact. So ಎರಡು object ಏನಿದೆ ನಮಗೆ ಕಾಂಟ್ಯಾಕ್ಟ್ ಅಲ್ಲಿ ಇದೆ, right? So when B is moving with respect to A or A will move with respect to B, right? With respect to means relative, as we already discussed the relative velocity concept in first chapter, that is motion in a straight line. So now B object now move ಮಾಡ್ತಾ ಇದೀವಿ ಅಂದ್ರೆ that object is moving with respect to object B, or if I am moving the object B with respect to moving an object A with respect to B means object A is moving with respect to B, that means relative motion. So relative motion of a object B with respect to A. So this object ಏನ್ ಮಾಡುತ್ತೆ, it opposes the motion of the object B, right? So ನಮಗೆ ಏನು ಗೊತ್ತಿದೆ, ಯಾವುದಾದ್ರೂ ಒಂದು ಆಬ್ಜೆಕ್ಟ್ ಗೆ ಫೋರ್ಸ್ ಅಪ್ಲೈ ಮಾಡಿದ್ರೆ ಏನಾಗುತ್ತೆ, ಆಬ್ಜೆಕ್ಟ್ ಮೂವ್ ಆಗೋದಕ್ಕೆ ಸ್ಟಾರ್ಟ್ ಆಗುತ್ತೆ. That means it gains some acceleration, that is from the Newton's second law of motion, right? So as if we apply the force onto the object starts to move, that means it gains some acceleration. So it has acceleration means the object is moving with some velocity, right? So as the object starts to move, so this motion of the object B will oppose by the object A, right? So that force we call as a friction, right? So friction is a force which opposes the relative motion of the object which are in contact. So ಇಲ್ಲಿ ಎರಡು ಆಬ್ಜೆಕ್ಟ್ ಕಾಂಟ್ಯಾಕ್ಟ್ ಅಲ್ಲಿ ಇದ್ರೆ ಮಾತ್ರ ನಮಗೆ ಎಕ್ಸಿಸ್ಟ್ ಆಗುತ್ತೆ. So ಕಾಂಟ್ಯಾಕ್ಟ್ ಇಲ್ಲ ಅಂದ್ರೆ there will be a no friction, right? So ಎಲ್ಲಿ ನಮಗೆ ಎಕ್ಸಿಸ್ಟ್ ಆಗುತ್ತೆ, so friction exists tangential to the surfaces in contact, right? So ನಮಗೆ ಎಲ್ಲಿ ಎಕ್ಸಿಸ್ಟ್ ಆಗುತ್ತೆ ಅಂದ್ರೆ tangent. So in the last class also we discussed this friction is a contact component of a contact force which is parallel to the surface, right? So parallel to the surface ಅಲ್ಲಿ ಯಾವುದಾದ್ರೂ force exist ಆಗ್ತಿದೆ ಅಂದ್ರೆ so that force ನಾವು ಏನಂತ ಕರಿತೀವಿ, friction, or we can define in either two definitions. ಯಾವುದಾದ್ರೂ ಎರಡು definition ಅಲ್ಲಿ ಯಾವುದಾದ್ರೂ two ನಾವು define ಮಾಡ್ಕೊಬಹುದು, right? So here the contact of the two objects is this portion. So ಇಲ್ಲಿಂದ ಇಲ್ಲಿಗಿರೋ portion ಅಲ್ಲಿ two objects are in, right? So there exists a friction, that means tangential to the surface. So ಈ ಎರಡು object surface ಗೆ tangent draw ಮಾಡಿದ್ರೆ so this is what the tangent direction of the friction. So friction is also a force, so it is also having a direction. So your direction irutte andre tangentially to the surface, either in this direction or in this direction, right? So again the friction is parallel, so that is F external, that is equals to 0, right? So now ಯಾವುದೇ object considered ಮಾಡಿದ್ರೆ always there existed two forces, right? So here we have a ground and the object is placed on the ground, right? So iduna one block anta considered ಮಾಡಿದ್ರೆ this block is placed on the surface, right? So here there is a contact between the ground and to that of the object, so there exists a contact force, right? So one component is parallel and another component is perpendicular, so there exists a perpendicular contact force. So this force we call as the normal force or reaction force. So now aduna always we represent that here, right? So this is for the normal force N, right? So next one more force is acting, so that force is the gravitational force. So each and every object will experiences the gravitational force and it is always directed towards the center of the earth, right? So this value is what, M into G, right? So as the normal force cancels the gravitational force or weight of the object, then the object is at rest. So again the F external applied force is 0, that means N cancels mg because both having the same, that is N is equals to mg, right? So N minus mg is equals to 0. So here we call this one as the external force. So N minus mg, we are getting the 0, hence the object is at rest, right? So now we will remove this one. So object rest ಅಲ್ಲಿ ಇದೆ ಅಂದ್ರೆ ನಾವು ಇವೆರಡನ್ನೂ ಕೂಡ ಕನ್ಸಿಡರ್ ಮಾಡೋದಿಲ್ಲ because again we getting that value is 0, right? So So now applying some external force F by pulling or pushing this object. So some force act ಮಾಡ್ತಾ ಇದೆ ಈ object ಮೇಲೆ, right? So that force initially some small force is acting. So initially some 5 Newton force is acting on this object, right? So ನಾನು 5 Newton ಅಷ್ಟು force ಈ object ಮೇಲೆ apply ಮಾಡ್ತಾ ಇದ್ದೀನಿ, push ಮಾಡ್ತಾ ಇದ್ದೀನಿ, ಅಂದ್ರೂ ಕೂಡ ಈ object ಏನಾಗ್ತಿಲ್ಲ, move ಆಗ್ತಾ ಇಲ್ಲ, right? So initially it restricts to move, right? So if it is to move means it should be acceleration that is of the order F by m. Again F is equals to m into a. So if we get the acceleration, then only the object will move, right? So this force is the applied force, right? So ನಾನು force apply ಮಾಡ್ತಾ ಇದ್ದೀನಿ, object ಏನಾಗ್ತಾ ಇಲ್ಲ, move ಆಗ್ತಾ ಇಲ್ಲ. So force apply ಮಾಡ್ತಾ ಇದ್ರು object move ಆಗ್ತಾ ಇಲ್ಲ ಅಂದ್ರೆ that means the object is at rest. So rest ಅಲ್ಲಿ ಇದೆ ಅಂದ್ರೆ again the sum of external forces which is acting on the object should be 0. So here I am applying 5 Newton. So this 5 Newton is not equals to 0. So that means there is a force which opposes the applied force. So ಯಾವುದೋ ಒಂದು ಫೋರ್ಸ್ ಇದೆ, ಆ ಫೋರ್ಸ್ ಏನ್ ಮಾಡ್ತಾ ಇದೆ, ನಾವು ಅಪ್ಲೈ ಮಾಡ್ತಿರೋ ಫೋರ್ಸ್ ಗೆ ಅಪೋಸ್ ಮಾಡ್ತಾ ಇದೆ, ರೈಟ್? ಸೊ ಅಪೋಸ್ ಮಾಡ್ತಿದೆ ಮೀನ್ಸ್ the same magnitude which is acting opposite to the direction of the applied force, right? So that is 5 Newton, right? So now 5 minus 5 we getting the 0, right? So ಇದನ್ನ ನಾವು ಯಾವುದೇ ತರದ್ದು ಫೋರ್ಸ್ ನ ನಾವು ಅಪ್ಲೈ ಮಾಡ್ತಾ ಇಲ್ಲ ಇದು, right? So that is the force which is obtained by the object which is in contact with the another object. So ground ಜೊತೆ ಕಾಂಟ್ಯಾಕ್ಟ್ ಅಲ್ಲಿ ಇದ್ದಾಗ ಒಂದು ಫೋರ್ಸ್ ಎಕ್ಸಿಸ್ಟ್ ಆಗ್ತಿದೆ. ಸೊ ನಾವು ಎಷ್ಟು ಫೋರ್ಸ್ ಅಪ್ಲೈ ಮಾಡ್ತಿದೀವೋ ಆಬ್ಜೆಕ್ಟ್ ಮೂವ್ ಆಗ್ತಾ ಇಲ್ಲ ಅಂದ್ರೆ ಸೇಮ್ ಅಪೋಸಿಂಗ್ ಫೋರ್ಸ್ is we are getting. So that force we call as the friction, right? So tangential means here is the surface in contact between the two objects. So tangent means we are getting the force. So this we call as friction F. So applied force e direction ಅಲ್ಲಿ ಇದೆ, friction e direction ಅಲ್ಲಿ act ಆಗ್ತಿದೆ. So applied force is equals to friction, right? So now 5 Newton apply ಮಾಡ್ತಾ ಇದ್ರೆ friction ಕೂಡ ಎಷ್ಟಿರುತ್ತೆ ನಮಗೆ 5 Newton, right? So now friction na always denotes, so ನಾವು represent ಎಲ್ಲಿ ಮಾಡ್ತಿದೀವಿ ಅಂದ್ರೆ when two objects which are in contact. So ಎಲ್ಲಿ ನಮಗೆ ಕಾಂಟ್ಯಾಕ್ಟ್ ಇರುತ್ತೋ ಅಲ್ಲಿ ನಾವು ಒಂದು tangent ನ ಡ್ರಾ ಮಾಡಿದ್ರೆ so that indicates what the friction, right? So friction is denoted by a small letter F. So applied force is always capital F and friction we denoted by always a small letter, so that is small f, and it is tangent to the surface of two objects, right? Now increase the applied force. So 5 Newton ಅಲ್ಲಿ ಇದ್ದ object ಏನಾಗ್ತಿಲ್ಲ, ಮೂವ್ ಆಗ್ತಾ ಇಲ್ಲ. So now I am increasing this to some 10 Newton, right? So 10 Newton ಅಷ್ಟು force ನ ಅಪ್ಲೈ ಮಾಡ್ತಿದ್ದೀನಿ. Again the object is at rest. That means the net external force should be 0. That means the frictional force is always equals to 10. So applied force increase ಮಾಡಿದಂಗೆಲ್ಲ frictional ಕೂಡ force ಏನಾಗ್ತಾ ಹೋಗುತ್ತೆ, increase ಆಗ್ತಾ ಹೋಗುತ್ತೆ. So ನಾನು 10 Newton applied force ಮಾಡಿದ್ರೆ friction force ಕೂಡ 10 ಇರುತ್ತೆ. That is equal and opposite, right? So next further I will increase this force to some 15 Newton. Again the object is not moving. That means the object is at rest. So again there is a friction, so that value is equals to 15 Newton. So 15 Newton apply ಮಾಡಿದ್ರೆ again we are getting the friction 15 Newton. That is equal and opposite, right? So ಇದು ಎಲ್ಲಿವರೆಗೂ ಆಗುತ್ತೆ ಅಂದ್ರೆ up to a certain limit. So now I will increase the applied force some 80 Newton, right? So that means initially 15 ನಾವು ಅಪ್ಲೈ ಮಾಡಿದ್ವಿ, ಅಂದ್ರೂ ಕೂಡ ನಮಗೆ ಆಬ್ಜೆಕ್ಟ್ ಏನಾಗ್ತಿಲ್ಲ, ಮೂವ್ ಆಗ್ತಿಲ್ಲ. That means the object is at rest. Now slightly increase the force from 15 to 18 Newton, right? So that time the object will starts to move, right? So rest ಇಂದ ಏನಾಗ್ತಾ ಹೋಗುತ್ತೆ, it starts to move, right? So with an acceleration a is equals to f by m. So this force we call, So ಅವಾಗ ನಮಗೆ ಫ್ರಿಕ್ಷನ್ ಏನಾಗುತ್ತೆ, this friction we call as limiting friction, right? So that force we ಯಾವಾಗ ನಾವು ಅದನ್ನ limiting friction ಅಂತ ಕರಿತೀವಿ ಅಂದ್ರೆ when the force we are applying the object starts to move, that means the maximum. So this value here I am applying some 18 Newton, so here also the friction will be 18 Newton. So this value we call as maximum static friction, right? So up to these values we call that one as static friction. Static means it will not changes its position, so that we call as a static, right? So now ಎಲ್ಲಿವರೆಗೂ apply ಮಾಡ್ತೀವಿ, up to a certain values we are applying the force, right? So after it crosses its limit, then the object starts to move, right? So that force we call as, that friction we call as the limiting friction, and limiting friction is equals to that of the maximum static friction, right? So static friction we denote it by Fs. So up to 10 Newton, 15 Newton, so ಈ ಎಲ್ಲ values ಗೂ ನಾವು ಏನಂತ ಕರಿತೀವಿ, friction. So that friction we call as the static friction. So this friction is a type of a friction, right? So static friction, how we define the static friction means, static friction we are defining, it is a force which opposes or which counterbalance the applied force, right? So static friction is also a force which counterbalance the applied force, right? So that type of friction we call as static friction, right? So now applied force is to applied act ಮಾಡ್ತಿರುತ್ತೋ, so same force we are getting in the static friction. So ಅದನ್ನ ಬ್ಯಾಲೆನ್ಸ್ ಮಾಡೋದಕ್ಕೆ ಒಂದು ಫೋರ್ಸ್ ಬರುತ್ತೆ, ಆ ಫೋರ್ಸ್ ನ ನಾವು ಏನಂತ ಕರಿತೀವಿ, static friction, right? So that static friction crosses its limits when we apply further force onto that object, then the object will start to move, right? So that friction we call as limiting friction, and that friction is denoted by Fl, right? So Fl is the limiting friction and Fs is the static friction. That is Fs we denote that one as static friction, right? So this limiting friction, so important is the limiting friction. So static friction means the object will be remains at rest. So now ಎಷ್ಟೇ force apply ಮಾಡಿದ್ರು there exists a force, so that force we call as a friction. So that friction we call as a static friction up to when, up to the object will be at rest. So rest ಅಲ್ಲಿ ಎಲ್ಲಿವರೆಗೂ ಇರುತ್ತೋ ಅಲ್ಲಿವರೆಗೂ the friction act ಆಗುತ್ತೆ. So ಆ friction ಅನ್ನು ನಾವು ಏನಂತ ಕರಿತೀವಿ, static friction, right? So when the applied force is equals to 0, so ನಾವು ಅಪ್ಲೈ ಮಾಡ್ತಿರೋ ಫೋರ್ಸ್ 0 ಆದಾಗ static friction value ಕೂಡ ಏನಾಗುತ್ತೆ, ನಮಗೆ 0 ಆಗುತ್ತೆ. That means the static friction will arise only when the applied force is acting, right? So ನಾವು applied, ನಾವು force act ಮಾಡಿದ್ರೆ ಮಾತ್ರ friction ಬರುತ್ತೆ. So ಅಂತ friction ಅನ್ನು ನಾವು ಏನಂತ ಕರಿತೀವಿ, static friction, right? So ಇದು important. So initially object at rest ಅಲ್ಲಿ ಇದೆ ಅಂದ ತಕ್ಷಣ ನಮಗೆ ಇಲ್ಲಿ ಯಾವುದೇ ತರದ್ದು static friction ಬರೋದಿಲ್ಲ. So static friction ಯಾವಾಗ ಬರುತ್ತೆ, when we are applying the force, right? So ನಾವು force apply ಮಾಡಿದ್ರೆ ಮಾತ್ರ ನಮಗೆ static friction ಬರುತ್ತೆ. So ನಾವು force apply ನೇ ಮಾಡಲಿಲ್ಲ ಅಂದ್ರೆ ನಮಗೆ static friction ಇರೋದಿಲ್ಲ. ಇದು ಒಂದು important point, right? So now last two chapters ಅಲ್ಲಿ study ಮಾಡಿದ್ವಿ, the object is moving in an uniform motion. So uniform motion means the object which is moving with constant velocity, right? So we say that one, the object is moving with uniform motion means the object who is moving with constant velocity, that means its acceleration is 0, right? So that type of motion we call as uniform motion, right? So here one more type of motion is there, so that motion is impending motion. So what is impending motion? Motion of the object due to the force. So that type of motion of object we call that one as impending motion. So force ಯಾವ ಆಬ್ಜೆಕ್ಟ್ ಮೇಲೆ ಆಕ್ಟ್ ಆಗುತ್ತೋ, ಸೊ ಆಬ್ಜೆಕ್ಟ್ ಏನಾಗುತ್ತೆ, it starts to move, right? So due to the force, the object is moving. So that type of motion we call as impending motion, right? So uniform motion means when acceleration of an object is zero, then that type of motion we call as uniform motion. So here force is acting means there is a acceleration. So here a is not equals to 0. So there a is equal to 0. So that type motion we call as uniform motion. So a is not equals to 0. Then this type of motion we call impending motion. There is a difference in uniform motion and impending motion. Wherever they mention impending motion, there is a force. Wherever they mention uniform motion, so there the force is 0. Right? Because F is equals to m into a, where a value is 0, then force is 0. So the net force acting on the object is 0. So that type of motion we call uniform motion, right? So here the force which is acting on a body due to its motion, so that we call as impending motion, right? So ಇಲ್ಲಿ apply ಮಾಡ್ತಾ ಇರೋ force ಗೆ it starts to move, right? So that we call as limiting friction. So limiting friction is denoted by FL, and we say that one as limiting friction is equals to the maximum static friction. So we can also write this one. So limiting friction is equals to the maximum of the static friction, right? So now certain force apply ಮಾಡಿದಾಗ object rest ಅಲ್ಲಿ ಇರುತ್ತೆ. So there exists a force, so that force we call as the static friction, right? So friction is nothing but force. So after crosses its limit, so small amount of force if we are applying means the object will start to move, so that we call as a friction. So that friction is the limiting friction, and that limiting friction is equals to the maximum of static friction, right? So FL is equals to Fs maximum, right? So here some laws of limiting friction, right? So laws of limiting friction. So we have the 2 points, so important points, right? So the limiting friction is independent of, in the short form I will write FL. FL represents what? Limiting friction, right? So FL is independent of area of contact, right? So limiting friction is independent of area of contact. So ನಮಗೆ ಅದು smaller area of contact ಇರಬಹುದು ಅಥವಾ larger area of contact ಇರಬಹುದು, right? So consider this example. So this is some object A. So I am placing one object B on object A. So here if you observe the contact surface between A and B, that means area. ಇದು one dimensional ಬರ್ದಿರೋದು. So two dimensional ಬರೆದ್ರೆ we are taking that one as area, length into breadth. So this area is very less, right? So if I am applying some 5 Newton force, again the friction will be, static friction will be 5 Newton, right? So if I am applying some 15 Newton, the object will start to move. That means the limiting friction L value is some 15 Newton, right? So same wise, if I am placing the object C here, so compare object B with object C. The area of contact between C and A is greater than the area of contact between B and A, right? So here also I am applying some 5 Newton force on object C. The same 5 Newton of frictional force which is produced between C and A. So same Newton is acting on the object C. The object C starts to move, right? So that means the limiting friction in object C is also Newton. So ನಮಗೆ ಏರಿಯಾ ಚಿಕ್ಕದಿರಬಹುದು, ಏರಿಯಾ ದೊಡ್ಡದಿರಬಹುದು. So limiting friction value ಯಾವಾಗಲೂ ಏನಿರುತ್ತೆ ನಮಗೆ ಸೇಮ್ ಇರುತ್ತೆ. That means it is independent of area of contact. So ಇಲ್ಲಿ area of contact some 5 millimeter square ಇತ್ತು ಅಂದ್ರೆ ಇಲ್ಲಿ 15 millimeter square ಇದ್ರು ಕೂಡ ಏನು ಡಿಫರೆನ್ಸ್ ಆಗುತ್ತಿಲ್ಲ, right? So limiting friction is independent of area of contact, right? So next, this second law is from the experimental observation, right? So limiting friction is directly proportional to normal force. So this point is very important. So while solving problems, this plays a key role, right? FL is independent of area of contact, so that is one factor. So second is FL is directly proportional to the normal force, right? So normal force is the force which is perpendicular to the surface, so that force we call as the normal force, right? So in mathematical form, we will write FL is directly proportional to L, right? So limiting friction is directly proportional to the normal force. Again, here I am removing the proportionality constant. So FL is equals to mu S N, where mu S is a proportionality constant. So now whenever we are removing the proportionality symbols to equals, one more term is added, so that term we call the constant. So A, B, C, D, but here we taken the friction that is constant, so that constant we call as coefficient of limiting friction or coefficient of static friction, right? So again, this we can replace. So from this, Fl is equals to Fs max, right? So we can write Fs max is equals to mu s N. So limiting friction is equals to mu s N, where mu s we call that one as coefficient of static friction. Where mu is a symbol where suffix s represents what? Static friction. Where mu s we call that one as coefficient of static friction. So this value depends on the nature of the surface of contact. So your nature ಇದೆ ಅನ್ನೋದ್ರ ಮೇಲೆ ಈ mu s value ಕೂಡ ಡಿಪೆಂಡ್ ಆಗುತ್ತೆ. So ಎಲ್ಲಾ ಸರ್ಫೇಸ್ ಗೂ ಸೇಮ್ ವ್ಯಾಲ್ಯೂ ಇರಲ್ಲ, ರೈಟ್? ಸೊ ಮಡ್ ಸರ್ಫೇಸ್ ಇತ್ತು ಅಂದ್ರೆ mu s ವ್ಯಾಲ್ಯೂ ಬೇರೆ ಇರುತ್ತೆ, ಸಿಮೆಂಟ್ ಸರ್ಫೇಸ್ ಇತ್ತು ಅಂದ್ರೆ ಬೇರೆ ಇರುತ್ತೆ, ಟೈಲ್ಸ್ ಸರ್ಫೇಸ್ ಇತ್ತು ಅಂದ್ರೆ ಬೇರೆ ಆಗುತ್ತೆ. So different surfaces having the different values, so that constant is called as mu s, that is coefficient of static friction. So frictionally, first important formula, this one is static friction. So object is just to start, so that value of friction we call as limiting friction, and that is equals to mu s N, right? So this normal force is equals to the weight of the object, right? So N is equals to mg. So we can further write Fs maximum, that is equals to mu s mg, right? So problem solve ಮಾಡಬೇಕಾದ್ರೆ ಈ ಎಲ್ಲ ಪಾಯಿಂಟ್ಸ್ ಕೂಡ ತುಂಬಾ ಇಂಪಾರ್ಟೆಂಟ್, right? Fs maximum is equals to mu s mg, where m is mass of the object and g is acceleration due to gravity, and its value is 9.8 meter per second square, right? So this is about the friction. So ಇಲ್ಲಿ friction study ಮಾಡಿದೀವಿ. Friction ಅಲ್ಲಿ two types. One is static friction. So object rest ಅಲ್ಲಿ ಇದ್ರೆ there exists a friction when we apply the force, so that we call as a static friction. When the applied force will crosses a certain limit, then the object will start to move, so that friction we call as the limiting friction, and that is equals to the maximum value of a static friction. So maximum value of a static, ಇದಕ್ಕಿಂತ ಜಾಸ್ತಿ ಆಗ್ತಿದ್ದಾಗ object ಏನಾಗುತ್ತೆ, ಮೂವ್ ಆಗಕ್ಕೆ ಸ್ಟಾರ್ಟ್ ಆಗುತ್ತೆ. So in this example, the maximum value of static friction is 18 Newton. So after if we apply some 20 Newton, the object will easily move on the surface, right? So main important points, now force apply ಮಾಡಿದ್ರೆ ಮಾತ್ರ friction ಇರುತ್ತೆ, force apply ಮಾಡಿಲ್ಲ ಅಂದ್ರೆ friction ಇರೋದಿಲ್ಲ, right? Next, applied force is always equals to the static friction. So ನಾವು ಎಷ್ಟು force apply ಮಾಡ್ತೀವೋ ಅಷ್ಟು friction ಇರುತ್ತೆ. So applied force increase ಮಾಡ್ತಾ ಹೋದಂಗೆಲ್ಲ static force ಕೂಡ ಏನಾಗ್ತಾ ಹೋಗುತ್ತೆ, that is static friction ಕೂಡ increase ಆಗ್ತಾ ಹೋಗುತ್ತೆ for a certain limit. So ಎಲ್ಲದಕ್ಕೂ ಒಂದು ಲಿಮಿಟ್ ಇರುತ್ತೆ. ಸೊ ಇದು ಲಿಮಿಟ್ ಕ್ರಾಸ್ ಆಗ್ತಿದ್ದಂಗೆ ಆಬ್ಜೆಕ್ಟ್ ಏನಾಗುತ್ತೆ, ಮೂವ್ ಆಗಕ್ಕೆ ಸ್ಟಾರ್ಟ್ ಆಗುತ್ತೆ. ಸೊ ಅಂತದನ್ನ ನಾವು ಏನಂತ ಕರಿತೀವಿ, limiting friction. So this limiting friction having two laws. So one is independent of area of contact between the two objects, and this limiting friction is directly proportional to the normal or reaction force. So idu ellinda bantu andre by doing the experiments. So iduna experiments ಮಾಡಿಬಿಟ್ಟು conclude ಮಾಡಿರೋದು. Fl is directly proportional to the normal force, and if you remove the proportionality, we getting Fl is equals to mu s, where mu s is a coefficient of static friction, right? So again we have n is equals to mg. So just substituting n is equals to mg, we get Fs maximum is equals to mu s mg, right? So next class we will discuss few more types of the friction. So only two types, one is static friction and another one is limiting friction. So in the next class we will discuss kinetic friction and rolling friction. So ಎರಡು ನೇಮ್ ಅಲ್ಲ ಇಂಡಿಕೇಟ್ ಮಾಡುತ್ತೆ. Kinetic means moving, rolling means rolling of one object on another object, we exists a friction, so that we call as rolling friction, right? Thank you. Any doubts?